Hi, in this tutorial I will teach you a little bit about recursion. I will show you some examples and together we will solve uh, some problems related to recursion. Uh, the recursion is basically a very popular phenomena in which we have a bigger problem and we divide this problem into smaller problems. And this is basically an approach which is widely used in divide and conquer methodology in algorithms. So before beginning the recursion, I will demonstrate it with a sort of a problem which we can solve with a recursion, and if we don't solve it using recursion, what can be the consequences and what actually a recursion is and how we can use it effectively in our daily projects. So basically it's not really a very complex thing. It's just you can say it's a sort of calling something properly, and if you know what you are doing and if you properly formulate your problem, then you can actually use recursion in a better way. And if you don't know how to use it properly and you cannot formulate your problem into recursion, then you cannot use it. So let me give you an example. Let's say I have this problem. I will represent it with the box. So I have different approaches I can use it to solve this problem. Let's say I want to compute the size of this box for simplicity. Because it's obvious, this is not a very good example, but just to show you how things will be going in recursion. So just observe this example carefully. Let's say we have this box and I want to calculate the size of this box. Okay, now you have different approaches. All you have to do is just calculate the complete length and width of this box and do it. But what if I divide this box into different chunks such that some of these chunks correspond to different rectangles, and then what will happen, I will be having these four sort of triangles, rectangles, and let's say I am just assuming this true. And what if I calculate the size of this one, then this one, and the rest of two, and after that I merge these and I have a single size of the box. This is in case a better approach, because if I am going to utilize all of my performance on a single operation of calculating the size of the box, then it's obvious that I may come up with a problem where I may not have enough resources for another processes. Later on, my memory will be ideal in the whole process. So why not I may use my complete memory, utilize some memory for storing these extra rectangles. And then after that, since this bigger problem has been divided into smaller chunks, and then I will use less computation. I will be using less computation to calculate the sizes, and then I will just recombine them. So I guess this is a better approach to solve the problem. Now to formulate this, now to explain this a little bit in more detail, You have all heard of a popular example in recursion where we have to calculate the factorial of a number. So how the factorial of a number is calculated. So factorial of a number is calculated basically, let's say if I have the 5, then the factorial of 5 is 5 into 4 into 3 into 2 into 1, which turns out to be 120. So what will happen that I have two approaches to solve this problem. Either I can use the for loop or I can use the recursion. So for the case of a simple loop, what will happen? I will just need a simple variable which will be such that factorial, and the loop will be such that it will start from this number and it will goes up to this number, and each number will be multiplied with each other, and hence we will have a final factorial. So for smaller numbers this is a good approach, but let's say if we have larger numbers, then maybe this is not a good approach, because the for loop is of single for loop is of the order of n, and so it will be such that it will goes up to something like, if we have 1000 numbers, so it will be order of 1000. In terms of the algorithms analysis, this is not a bad approach, but always we are trying to reduce the computational complexity, the time complexity, and the space complexity. So in this case, we are not managing our resources efficiently. We want that our space and time complexity may be somehow balanced. So the another approach is using recursion for calculating the factorial, which will be something like, if I want to calculate the factorial, so I can only have the factorial will be equals to the which number, the first number, and this will be multiplied with the n will be multiplied with the factorial of the previous or the next number, depending upon how you are designing things. So once this recursion function is run, so how you will use it and how it is stored in the memory. So if this is run, so let's say I have got function of factorial and it just take an n. So if I let's say I just provide here a direct number here, the fact will be equals to the times of the fact multiply with the sort of n here, just n here, and this will be multiply with the previous number. This is the overall how you can formulate this function. Is you can see that the function has been called within a function, and how this will in turn out. So let's say if I pass the number 5 here, so what will happen that 5 will first come here, then the multiply sign, and the factorial will be called again. The factorial function will be called, and since it is calling 5 minus 1, so 4 will be called here. Okay, here 4 will come and here will be 4. So next time this formula will be 4 into factorial 4 minus 1. So 4 will be here. Okay, now here is now 4 minus 1, so 4 minus 1 will turn out to be 3 here. So the 3 will come here. Okay, so once the 3 will come here, its next time it will be 3 into factorial 3 minus 1. Okay, and so on for the rest of the process. But here is a problem. It's a bigger problem. Let's say I have a number here. Let's say 1 in turn 1 is here. So 1 minus 1 in turn here is 0. So 0 multiply with these whole numbers will be equals to what? It will turn out to be 0. So we have to stop this. So how I am going to stop this? I have to give a condition here such that if n is greater than 0, then you are good to go. But once the n becomes 0, then you have to break this. So this is now the complete function. So our function will just come to here and it will generate the 120 for us, and the factorial will be returned to us in the wherever you call this function. So let's create a function here of the factorial. We'll just call it factorial and we'll just provide it a number. Now I will just declare a variable here, factorial 1. Then if the n is greater than 0, all you have to do is n into factorial here. I am unable to call the, if I'm not wrong, okay, it's here, this n minus 1. Okay, everything is correct. Now I will just provide, I will just use the actual process here. Okay, now factorial equals to factorial, and I will provide this number, and then let me print this on the screen. As you can see here, I have got 120, and if I provide here the 3, so it's 6. If I provide 20 here, so it will be somehow a number. I have to just fix it and turn this to be a long, so it provides me a reasonable amount of correct numbers here. This is a correct number now for a 20. So this is how things are formulated. Now we will see how to formulate the recursion formula for different things. So it's a little bit based upon the work done by you, and you have to calculate the formula for yourself in some cases. But for simplicity, I will show you a simple example. Let's say you want to sum up all of the numbers in an array. I will just write it down here. So an array consists of a sequence of numbers. So what do you think? What will be the sum of this array? So it's turned out to be 3, 6, 10 and 15. So 15 is the sum. Now I have two approaches. I can use a for loop or I can use a recursion here. So if I'm going to do this with a for loop, so how I'm going to do this? Return sum, and I will just provide a vector. Now here it is. I have to just provide the, and then I have to return the sum. In this case, if I am having a vector, then the return sum will just return for me the sum, which will be equivalent to 15. Now if I want to do this with the help of recursion, so the approach would be somehow return recursive sum int vector, and with the vector I have to provide the n, total number of the numbers. Then I have to provide a base condition. If n is greater than 0, then I have to provide the variable here, the sum. The sum will be eventually equals to the actual number of the vector plus the return recursive sum, and that will be the actual vector and n minus 1. So we will be having here for the first time 5, then 4, 3, then 2, then 1. So at the end I have to just return the sum. Now I have to just call the return recursive sum. I have to after this I have to check this whether this is properly working or not. I will just click start. As you can see, I have the 15 and 15 for both of the print statements on the screen. As you can see, I have achieved both of the logic using a plain loop here and using recursion. Now I can utilize this return recursive sum in many ways, such that, let's say I have here an example, return sum matrix. I want to sum out the matrix, but I will be using this return recursive sum here. Here I will pass in a two-dimensional array here. This will be matrix, and for the sake I will just pass the number of rows here. Now I will do the plain logic of the for loop using this following function. I won't be using any recursive paradigm, just plain old for loop. So how this is, I will just fetch a row which will be a new int basically, and since the matrix rows have a fixed size, so I will just fetch a column which will include all of the number of elements in the row. So I have got the row here, and then I will just loop out this matrix. After that I will call this return recursive sum here, But before that I have to pass the corresponding uh, row to this vector array. So I have to create another function by the name of fetch row, and it will just take the matrix from me and the row number. I will just use some of the code from here. Now the loop will go from the specific element to the last element, which will be the corresponding row, and the row number and the ith will be basically equals the row I will be equals to just the matrix I, row number and the I, and at the end I have to just return the row. Now I will use the row equals to fetch row and will pass this matrix and the row number, and after that I will pass this return recursive sum, and I have to pass this row and row dot length -1. Okay, and this will return a sum for me. I will do this here. Sum equals to sum plus return recursive sum, and then I will return the sum to the user. So code is complete. I'll just remove these lines and then I will pass 1 2 3 and then 4 5 6 and then 7 8 and 9. Then I will just return some matrix, and then this matrix will be passed, and the number of rows basically get length and -1. So I will just run it, and you can see I have got 45, which is actually the sum of the complete matrix, and it's perfectly working. Now I will sum up this tutorial with the last function. I will also create this function recursive, so how I can use this as in a recursive manner. So it's pretty straightforward. And this will be return recursive matrix sum. It will fetch the matrix, then the rows, and after that, if the rows is greater than 0, all you have to do is provide me a sum. Sum will be equals to which thing? This sum will be equals to the return recursive matrix sum, or since we are fetching the row from here, So we have to provide the row, and this will be this one. After that, I have to fetch the row, and this will be basically the same as we have done. So this row will be basically this rows in LAM terminology. I will just hit it row. Okay, so we have to pass the row number and the corresponding row here. I will just call it fetched row. Now all I have to do is I have to use this return recursive sum here. Return recursive sum. I have to pass the fetched row and fetched row dot length -1, and after that I have to pass on the return recursive matrix sum, and inside this I have to pass this matrix and then row -1. So code is pretty complete, and then I have to return the sum to the user. So as you can see here, I have declared a variable sum and a fetched row. This fetch row will be helping out in fetching the row from this specific matrix, and then the sum will be calculated based upon the return recursive sum. Inside this return recursive sum, we will pass the fetched row and the fetched row length. We will subtract 1 from it. Then we will add up with the return recursive matrix sum, because the function has to call itself, and the matrix and the row will be subtracted by 1. The base condition is if row is greater than 0. Inside this we have to no, I guess we don't need this. So I will pass return recursive matrix sum here and hope so it to work. As you can see, it has given me a wrong answer, 39, and I think this was the reason, because it was not fetching the 0th row. So this was a little very minute bug here. It was fixed. So as you have seen here, this was the overall paradigm how we have to use the recursion in our day-to-day applications. In the upcoming tutorials, I will show you some advanced examples of recursion, and as you have seen the power of recursion, so it divides the actual code into some chunks, and these chunks are then solved and then recombined, sort of a phenomena which is a divide and conquer approach to a bigger problem. Thank you, and for any questions please leave it in the comment section and I will catch you up there. Thank you.